Hey, what's up, guys? Welcome to my YouTube channel. In today's video, I want to show you how we can make this simple web app using Streamlit in Python. Now, for those of you who do not know Streamlit, it's a very simple, easy to use open source Python library that helps you create and share beautiful web apps. So I'm gonna, if you wanna read more about Streamlit, I'm gonna post the link in the description below so you can read on your own how to use it. So the web app that we are going to make in this video, we are going to use the infamous Titanic dataset, and it's gonna look like this. It's gonna be very simple. First of all, the first thing you're gonna see on the web app is this picture of the Titanic, and then on top we'll have this title: "Predict Your Survival on the Titanic using a Deep Neural Network." And then down here, you can see that it's going to say whether you survived or not. And then we're going to print the training and validation loss of the model down here, as well as the training and validation accuracy of the model. And on this here on the left side, you're going to have this sidebar where you can select your, let's say you are a passenger on the Titanic. You can select the class you are in, whether you're male or female, your age, the number of siblings on board, the number of parents on board, and the fare that you pay to get on the Titanic. And then the model is going to predict, based on this data that you put here, it's going to predict whether you survived or you didn't. Okay, so let's get started. So to get started, I do have this Titanic dataset. I'm also going to post this in the description below in case you want to use the exact dataset. And this is what we're going to do. First of all, let's just import all the libraries that we're going to use in this model. So far, I think these are the libraries that we're going to use. I'm not sure if we're going to use all of them, but we're just gonna import all these libraries, and then we can get started. So we're just importing pandas, NumPy, Matplotlib, Seaborn, TensorFlow, Keras, Streamlit, as well as Pico and Pillow. Like I said, Streamlit is a very easy to use and straightforward framework, and to show you that, the first thing you can do on your web app is just say something like st dot title, just like that, and then in the parentheses you put whatever title that you want your web app to say. So we can say this one is going to be called "Predict Your Survival on the Titanic," just like that. I'm not going to run this now because it takes time to run this server. If I keep running it every time we write one line of code, then we're gonna waste so much time. So let me just write a few other lines of code, and then we can run it and see what it looks like. And then if you wanna have an image on there, all you have to do is say define an image. Let's say this variable of an image. We say image is equal to image.open. So we're using this image that we import from Pillow, and it's actually like that. Image like that, yeah. Open, and then you open the image file that you want. My image file is called titanic.jpg. So in my directory, I do have this image of the Titanic. This is the one that we're going to use. So yeah, just like that. And to actually put this image on the web app, we say st short for Streamlit dot image. And then in the parentheses we can pass our image variable that we defined up there, and then we want the width to be, let's just give it a width of 600, and then channels, we're gonna say RGB channels, RGB, just like that, channels RGB. What else can we add here? We can say caption. Caption is going to be equal to none. The caption is equal to none. And now to actually run this web app, we can go to our command prompt. I'm using Anaconda, so I'm just gonna open my command prompt like that. I'm gonna copy and paste the directory of my web app. Then in the command prompt, cd into the directory. Okay, I'm sitting there. And then to run the web app, all you have to do is say streamlit run of my Python file is called titanic.py. So I'm just going to Streamlit run titanic.py. Hit enter, and it's running. It opens the web app, opens in a browser, and there we have it. We have the title and the images down here. And to create the model, we need to define, let's define the data frame. Data frame is equal to, we're going to use pandas to read this data frame, pd dot read CSV, I'm sorry, CSV, and our file is in the same directory, and it's called titanic.csv. Let's open this file just to show you what it looks like. So this data frame that we're going to use is this one right here. You see, it's good. The survived column, this is a column that we want to predict. So this is going to be our Y, and everything else is going to be our X. Based on experience, we know that the name of the passenger does not contribute to the survival of the person on the Titanic. Okay, so we are going to drop this name column here. It's not useful to us, and then we're going to leave everything else. So to do that, to drop the name column, you know, it's easy. What we do is df is equal to df dot drop. We want to drop. You say columns. So now here we can put all the columns we want to drop. We're going to drop the name column. Okay. I'm going to put some comments here. Okay, we say drop the name column because it's useless. And then here we're going to do another thing. We're going to say, what are we going to do here? We're going to encode the sex column. The sex column here, it says male or female, but you know, we cannot feed these variables male or female in the model. We need to change this into zeros and ones. So let's make the males ones and the females ones. And this way we can easily feed all this data into the neural network. This is what we're doing by encoding the sex column. So to do that, encode the sex column, we do df dot log df the sex column. So sex column, say where it says male, where it says male, the sex is going to be 1. So what we are saying here is that we are going to change the data frame, you know, in the column sex. Everywhere it says male, we are going to change it to 1. And then we just copy and do the same for female. Here we say female. And here we say 0. So every female is going to be 0 and every male is going to be 1. We can now split the data into independent X and Y variables. So we can say split the data into independent X and Y variables. X is equal to, so like I said before, the first column, the survived column, is going to be our Y. This is what we want to predict, and then everything else is going to be X. We want to drop the survived column from X. X is going to be everything from here all the way here, and we also drop the name column, by the way. So we first have to drop this survived column from X. To do that, we say X is equal to df dot drop survived, and axis is equal to 1. And then now we can define the Y. We can say Y is equal to df. So Y is only going to be df to survive. It's going to be the survived column from the df. So Y is going to be just like that. And let's just add, you know, let's just change the data type. You know, you can look at this column. You know, I don't know what data type this is. I don't know, these are integers or just you know, or float variables. Let's just to be sure, let's change the data type into float, so that we don't encounter any problems when feeding it into the neural network. So we can say y is equal to df survived, and then we say dot values dot as type np numpy dot float. Let's just use float 32. I think we can leave y just the way it is without changing the data type. But okay, let's just change x as well. X is equal to x dot values, and then dot as type np dot float 32. Now we can define the x train, the x validation, y train as well as the y validation is equal to test split, and then in the parentheses we put x or y. The test size, let's just put it to 0.2. Test size is equal to 0.2, and then the random test is random state. Random state is going to be let's just put it 1. I think it's fine. It's going to work. Okay, let's just and now without wasting too much time, I'm just gonna down here, let me just copy and paste the model. Now I'm gonna go through what this model is doing. So I'm creating a variable called model, and this model is going to be equal to keras.sequential model. We imported keras up here. First, adding here a flattening layer with an input of 6. So why are we using an input of 6? So if we look at the data frame, you see it's good. This is the y, so it doesn't count, and we are only counting the x. So we have 1, 2, 3, 4, 5, 6, 7 columns, but we did drop the name column, so we are only remaining 6 columns. So this is the input. So that is why the input shape here is equal to 6. And then after the input layer, after the flattened layer, we're going to add 6 dense layers, and then 4 dense layers, 2 dense layers, and the last layer with an activation of sigmoid. After every layer, you can, you have to add an activation layer, an activation function. In my case, I'm using relu here for the first 3 layers, and then the last one I'm using sigmoid. Now you can try different types of activation functions, see which one works best for you. You can say down here, model.compile optimizer. Let's just use Adam. The laws are binary cross entropy, because this is a binary this is a binary classification. We are only trying to predict whether somebody is going to survive or not. So there's only 2 outcomes here. And then the matrix is going to be equal to ACC, which is short for accuracy. We're just defining our history, and we say history is equal to model.fit, x train, y train, the number of epochs. Let's just use 120 epochs. The batch size is equal to 1. The validation data is equal to the x validation and the y validation. So down here we can let's define the loss of the training. Let's say the loss of the training is equal to history. Oh, yeah, it's written like history, and then history loss. And then the loss of the validation, we can define it as equal to history validation loss, like that. And then now we can plot everything using NumPy. To do that, let's just define the number of epochs. The number of epochs is equal to 120. We are going to say epochs is equal to range It's going to range from the first one to the last epochs. From 0 to 119, or from 1 to 120. So epochs is equal to range 1 to 120. Then to define this figure that we're going to play this data in, we say figure and axis is equal to pillar t dot subplot that. And now we can use the next thing we can do is use this axis to scatter the data. So we do that by saying x dot scatter. I guess it's scatter. I think so. Scatter this data, and we're just gonna scatter it in on. So say 0.25, 0.25, like that. To plot the data, we say plot. What we want to plot is we want to plot the for the number of epochs. We want to plot the loss train, the loss of the training. So we say loss train, and we're gonna label. Let's plot this in green, and then let's just label this. The label is going to be equal to training loss, like that. Then we can also plot the loss of the validation like that. Let's say we just change this to loss validation, and then let's plot this in what color? Let's say blue, and then here we say validation loss. And then to have a title on this plot, we say plt.title. We say this title is going to be called training and validation loss. Like that. On the x-axis, we're going to have the number of epochs. So x, we can say plt.x label. X label is going to be epochs, number of epochs. Y label, plt.y label. The y label is going to be, we're going to have the loss. To actually show this figure, we say plt.show, like that. Before we run it in the web app, let's just run it here to see if we get any errors. We should not have any errors. So it's gonna run this model for 120 epochs. We get an error here. It says history object is not subscriptable. Why are we getting this error? Let me see. Okay, I know. You know what, guys? Just up here, let's just save this history. You know what? Let's first of all the model. Let's save the model here. Let's just say model dot save, so that next time we want to use it, we can use it directly without having to run it all over again. So let's say model dot save. Let's just name it Titanic dot h5. So you can save your neural network like that just by saying model.save, whatever name you want to save it, and then this file type is going to be h5 file type, just like that. And then down here we can save our history. We say with open. Let's say this is the training history. Training history. And because we're going to write to this file, we're going to say like that, WB. We're going to write to this file with open as file. And then we're going to use Pico. We did import Pico, did we? Yeah, we imported Pico here. We are going to save this training history into a Pico file. So we have to do is say with open as file, and then Pico pico.dump. So to save a file into a Pico file, all you do is say pico.dump. Then we're going to dump the history. file like that. Now that we've saved this file, we can actually read from this file. Down here, we can redefine our history and say history is equal to pico.load. So again, to read a pico file, all you have to do is say whatever name you want to give it, and then say pico.load. So we are going to load this name. What is it called? Pico.load. You actually first have to do pico.load, and then you say open what? We are open this file that's called training history. Training history. Because when I read from this file, we can say RB like that. Yeah, I'm getting errors here. What are we doing wrong? Okay, we forgot one curly bracket here. They should be fine now. Now we save this file. Let's run it again. We should get no errors now. It's running again from epochs number 1 to 120. And there we have it. You see, guys, we got our training and validation loss. So it's dropping with an increasing number of epochs. Our training and validation loss is decreasing. So we can maybe increase the number of epochs a little bit here, but I think for the purpose of this video, I think it's enough for now. And you can see here, the accuracy is already 0.82. So we've reached an 82% accuracy. Now we can also plot apart from plotting the training and validation loss, we can also plot the accuracy. So to plot the accuracy, we're just going to do the same thing as the loss. The only difference now is that, so I just copied and pasted this here. Let's just remove it first. So the only thing that we're changing here is from here you change loss, here it's accuracy, validation and loss, here it's validation accuracy, and here we change the labels. You know, here it's training loss, but down here it's training accuracy, that validation accuracy like that, and then yeah, so it's basically the same thing we are plotting here. We're just changing the variables here. So we can run it again and see what our accuracy looks like with an increasing number of epochs. We made a mistake here. Oh, it's right. Lost trend history, don't you know? It's supposed to be just history. So let's remove that. And then let's remove that. Yeah. Now run it again. Should be fine. Okay, and there we have it. As you can see, with an increasing number of epochs, our accuracy is also increasing up until somewhere there 0.8 something. It stops increasing. So this tells you that maybe we need to change the model, maybe you know, correct some things in the model to make it better so that it keeps increasing the increasing number of epochs. But I think we don't have to do this now. This accuracy is okay for the purpose of this video. So now let me show you something, guys. If we go to a web app, you know, it's just showing the title and this image. But here we do have these other figures. So to actually show these plots in our web app, all you have to do is down here, you got to say st.pyplot, and then in the parentheses, you just put this figure. Okay. We copy this and we paste it down there. st.plot the figure. I mean st.pyplot the figure. We save this file and then we run it. We run our web app, and now it's running. So it's done running, and we scroll down. You can see now these figures are showing training and validation loss, and then the training and validation accuracy. Awesome, isn't it? So next thing we can do now is put this sidebar here where the user can choose the class, whether they're male or female, and the other variables, and then we can use those variables to predict whether they survived or not. So let's do this, and we're gonna do this up here. You know, just up here. Let's define a function. Let's just call this function survival. Let's make a variable. Let's call this p class is equal to st.sidebar, I guess. Yeah, it's sidebar. st.sidebar.slider. So we want to have a slider on the sidebar. So all you have to do to have that is say st.sidebar.slider. Streamlit is very easy. It's very convenient and easy to use, straightforward. And then we want this sidebar to say the name of this sidebar is this slider is going to be P class, and we want this someone to be able to slide this sidebar this slider from they can slide it from 1 to 3 because there were only 3 classes on the Titanic: class 1, class 2, class 3. Sex is going to be equal to st.sidebar dot select box. So this one is going to be a select box. They should be able to select whether they are male or female. Select box like that. The label is going to be equal to what am I doing? Going to be equal to sex. And then the options of this select box, we're going to have male and female. And then for the edge, we're going to use a slide bar for the edge. So we're going to say, we're just going to copy this. Edge is equal to st or sidebar or slider. And then the label of the edge is going to be equal to edge. Then their edge is going to range from let's just say 0 to 80. I did not look through the data in the Titanic data set, but I think there were people who were like something 80, 70 something years old. I think so. Then we can define the number of, let's say, we're going to go this one, number of siblings. Number of siblings, spouses. Is equal to st.sidebar.slider is also going to be slider. And then the label is going to say number of siblings or spouses. And let's just say they had either they had 0 to, some people had 0 siblings and spouses. So we're going to say it's going to range from 0 to 5. Maybe some people had 5 wives and 5 siblings on there. I don't know. I think, no, let's just say 0 to 3, I think. Yeah. 0 to 3. And then the number of parents, children is going to be equal to also a slide bar. Someone can have as many as 5 children, so we can say this one is going to range from 0 to 5. So number of siblings, number of parents or children. Let's put everything in the same format. This one, yeah, like that. So the number of parents, siblings is going to be from 0 to, let's say, no, let's just leave it 0 to 3, okay? And the amount they paid on the Titanic, which is the fare, is going to be equal to, also going to be a slider. ST to sidebar to slider, and then this is going to say fare. They paid anything from around 0 to, I looked through the data. I think there's some people who paid something like $100, something like that. So we're just gonna put something from 0 to $200. Yeah, something like that. And now remember up here when we are defining our model, we did encode the sex column. So males are 1s and females are 0s. So here to be able to feed this data into the model again to predict whether this particular male survived or not, or this particular female survived or not, we also need to change this data. So we're going to say if sex is equal to male, if sex is equal to male, then sex is equal to 1. or else 6 is going to be equal to 0. And then we can put all this data into an array by saying data is equal to, this is going to be an array, p class, and then we get sex, what else we got, age, we get number, like that, number of siblings, spouses, and then we get number of parents or children, and then we get the fair. Now, to be able to fit this array into our model, we have to change the data type. So we can say data is equal to TF, short for TensorFlow, TF dot constant. Data. So this is just going to change this array into into a tensor so that we can fit this tensor into the neural network. And then we just want to be able to return the data from this function. I'm seeing an error here. Where is it coming from? So we got here's age, number of siblings. Oh, like that. We misspelled it here, so let's change it. So children, the fair, but I'm still seeing an error. I don't know. It's going to have 1, 2, 3, 4, like that. Yeah, 1, 2, 3, 4, like that, like that. Now it's okay. Down here, I'm just going to create a variable. I'm going to call this survived or not. Survived or not. And it's going to be equal to this function. It's going to be equal to survival. The name of the function is going to survival, like that. And then I'm going to make a variable called prediction. This to predict. I'm going to say prediction is equal to model dot predict. Model dot predict survived or not. Survived or not. In steps of 1. This prediction, by the way, is going to return a variable between 0 and 1, but we need to be able to round it off to zeros and ones. So if it's anywhere near 0, it's just going to be 0. If it's anywhere near 1, we want it to be 1. And to do this, we create another variable. We call this predict. We round it off by saying round. We're going to round x to 0. For x in prediction. So for prediction, yeah. So for each one of these predictions, we are going to round it off to 0 if it's closer to 0. Otherwise, it's going to be 1. So, and to actually print that prediction on our web app, we can just say down here, if prediction is equal to 0, let's look at our data again. So if 0, then somebody did not survive. If it's 1, then they survived. Okay. So if a prediction is equal to 0, you can say st dot write. So this is how you write something on a web app using Streamlit. All you have to do is say Streamlit dot write and then whatever you want to write. So in this case, we want to say Streamlit dot write. You did not survive. You did not survive. Or else, if it's something else other than 0, then it's going to be 1. And then we're going to say st dot write. You survived. Just like that. Okay, now we are going to save this file. Let's go to our web app. Let's rerun it. Right here on the web app, you have these options. You want to rerun it, you can just say rerun like that. It's running the model again. And then we should be able to see the sidebar here and the prediction down here. It's done running, and there we have it. You see, guys, the sidebars are showing clearly. The edge is showing negative 80 to 100. There's something wrong here. Let's let's change this. It's supposed to say 0 to 80. Let's see. Okay, so here I see where the error is. Supposed to say ST or sidebar or slider. The label is age, and then it's going to say 0 to 80, 0, 80, like that, not 0-80. So that is why we save it again. Let's rerun it again. And yeah, there we have it. So we have the sidebar. Everything is showing the way it's supposed to be showing. And the image is here. The training and validation loss on the model. And I know what, let's predict, let's say here it says you survived. But let's say somebody like me, I'm a male, I'm in class 3 because I don't have money to pay for the class. I'm a male and my age is between I'm 25. My age is 25. And I've got no siblings and spouses on board. I've got no parents on board. And I paid, let's say I paid something like, because I'm a poor guy on the 3rd class, I probably paid something like, $7, okay, $8. Then the model is going to run again using my data and see if I survived or not. Discuss. And there we have it. It says you did not survive. So using the data, I did not survive. Okay. And let's predict again for somebody else. Let's say they're in class 1 and they are female. And their age is between, she's a beautiful woman between the ages of 18 and 30. Let's just say let's just make her 30 something. She's 37. She's got a husband on board. She's got one husband. This is not moving. For some reason, I'm getting, the slider is not moving. And because she's a rich woman, she paid something like, let's say $80 something. And she's got one, oops. By the way, guys, I just realized there is a mistake here. There is a typo here. This is supposed to be spouses with an S, not a C. But anyway, it doesn't affect the result. But still, let's go and change it. So let's just change this S. This is supposed to be S like that. This one, S as well. No, like that. Spouses. And okay, and I'm gonna save it again, and then I'm gonna reload this page again. Here we have it. Now let's try to make a prediction for ourselves. Let's say I'm somebody like me. I'm a poor guy. I'm in class 3. I'm a male, and I'm between the ages of 20 and 30. Let's say I'm 25. I've got no spouse or siblings on board. I've got no children on board. And because I'm a poor guy, I only paid about, let's say $9. So the model is going to run again and it's going to predict whether I survived or not. And it says you did not survive. And I was expecting that. And as we already know, on the Titanic, most of the people that were in class 3, they did not survive. Most of the males did not survive. So let's say there is another beautiful girl on the Titanic. She's in class 1, that's class 1. She's a female. She's about 30 something because she's already married. She's about 30, say 37. She's got one husband on board. She's got no children. And she paid a little bit of money. Let's say something like $80. Yeah, so let's make a prediction for this lady. So I'm expecting her to survive because, as we already know, most of the people that survived on the Titanic were in class 1 and they were female. So let's see what our prediction says. And it says you survived. So as expected, there we have it, guys. And this is the end of the tutorial. There's a lot of other things we can do here. But for the purpose of this video, I think I'm gonna stop here. If you have any questions or suggestions, let me know in the comment section below. Don't forget to subscribe and like this video. Thank you. See you next time.